Good morning everyone and welcome to the Q&A session 25 from the playlist of work, power and energy. The topic is the work done by a variable force, and based on this topic I have selected one question which was asked in the IIT-JEE main examination in the year 2017. So the question here is force acts on a particle given by F is equal to 60 where T is the time in seconds and F is the force in Newton. Now if this particle of mass 1 kg starts from rest, and the work done by the force during the first 1 second is. So here we have been given 4 options and we have to find the correct one. So here we will be using the Newton's second law, that is rate of change of momentum is equal to the applied force. So from here we can write dp is equal to f dt. Now f is equal to 60. So dp will be equal to 60 dt, and simply we will integrate this equation. So this equation can further be written as integration of dp, this is equal to integration of 60 dt, and this equation, so I will be getting the equation for the momentum as the integration of 6t dt will be equal to 6t square upon 2, so this is equal to 3t square plus the constant of integration. Now since the body is starting from rest, therefore it's at t is equal to 0, p will be equal to 0. So the value of c will be equal to 0. So p is equal to 3t square. Now at t is equal to 0, p is equal to 0, and at t is equal to 1, p will be equal to 3. At t is equal to 1 second, p will be equal to 3. I will be simply putting the value of t is equal to 1 in this equation. So p, the momentum will be equal to 3 kg meter per second. So now the next important step here will be the utilization of the work energy theorem. So from 0 to 1 second, the change in the kinetic energy has to be calculated. Now here the momentum at t is equal to 0 is equal to 0, and at t is equal to 1, this is equal to 3 kg meter per second. Now we know that the kinetic energy is also equal to p square upon 2m. So at t is equal to 0, the kinetic energy, or we can say this is the initial kinetic energy, this is equal to 0, and at t is equal to 1, the kinetic energy will be equal to kinetic energy at t is equal to 1 second. This is equal to 9 divided by 2. So the change in the kinetic energy will be equal to 4 by 4.5 joule. Now as per the work energy theorem, the change in the kinetic energy is equal to the work done. So the work done here, the work done by the force during the first 1 second will be equal to 4.5 joule. So in this question we have used the Newton's second law and the work energy theorem in order to find the work done by the force during the first 1 second. So thank you very much for joining. In the next session I will be coming up with a different question, and probably it will be from either from the NCERT exemplar or from the IIT-JEE this previous year examination, or from the board examination also. So till then, have a nice day. Bye.